Okay, I've seen there's some difficulties in differentiating expressions which look like this. Oh, this is an equation, not an expression. So this is what you do. We're now going to change it into a gradient equation. This number here, this index, this 4, is written there. You then must differentiate what's inside the bracket, which in this case is 3. You multiply with it. The contents of the bracket remain the same, and the index goes down by 1. We now simplify what we have. And that is the answer. Here is another example. This time we must prepare the equation for differentiation. So we don't want to see a fraction, we want to write this in the denominator, but because it's at the moment we want to write this in the numerator, at the moment it's in the denominator, so we're going to have to pop it in some brackets and give it the correct power. Notice it's negative because it was in the denominator. Power of a half indicates it's the square root. Now the procedure's much the same. The gradient equation, this comes to the front, where it multiplies what it can see. Remember, this didn't happen in the first example because there was no multiple of the parentheses. We now differentiate the contents of the bracket, which is -1, and multiply with that. The contents of the parentheses remain the same, but the power goes down by 1. Now we're going to simplify what we've got. In the numerator, we've got 3 times -1 times -1, so it's just 3. And in the denominator, we've got the 2, and we've got this 4 minus x to the 3 over 2. Let's just make some sense of this. The 2 in the denominator of the index implies that it's the square root, just as it was here. We had the square root was to the power of a half, in this case the negative a half because it was in the denominator. So the fact that we've got the half in the, the 2 in the denominator implies that we've got a square root, but it's raised to the power of 3. So I finish off writing it. 3 over 2 times the square root of 4 minus x cubed. Now you can just, what I would do is I would always calculate the square root first, root before you raise, so all of that is raised to the power of 3.